Did you know that the global blockchain market is projected to reach significant valuations in the coming years? This growth highlights its increasing relevance across various sectors. However, a common question remains: what exactly is blockchain, and how does it influence the landscape of cybersecurity? Welcome to this video. Our purpose today is to provide a clear, objective overview of blockchain technology. We aim to demystify its core concepts, explore its practical applications in cybersecurity, and discuss both its potential benefits and inherent challenges. This discussion is designed for anyone interested in understanding this evolving technology beyond its association with cryptocurrencies. Let's begin with a foundational question. What is blockchain? At its core, blockchain functions as a decentralized, distributed ledger. This ledger records transactions or data across a network of computers rather than relying on a single, central authority. Each record or block is cryptographically linked to the previous one, forming an immutable chain. This structure means that once a transaction is added to a block, and that block is appended to the chain, it becomes exceptionally difficult to alter. The distributed nature ensures that multiple copies of the ledger exist across the network. This redundancy enhances data integrity and resilience against single points of failure. The process of adding new blocks involves a consensus mechanism, such as proof of work or proof of stake. These mechanisms ensure that all participants agree on the validity of new transactions before they are recorded. This collective agreement is fundamental to maintaining the integrity and security of the entire blockchain. Cryptographic hashing plays a crucial role, creating a unique digital fingerprint for each block. Blockchain technology introduces several characteristics that are particularly relevant to cybersecurity. Its inherent design offers potential solutions to some long-standing digital security challenges. These attributes contribute to a more robust and transparent security framework. Firstly, decentralization significantly reduces the risk associated with centralized data storage. In a traditional system, a single server or database can be a prime target for attackers. With blockchain, data is spread across numerous nodes, meaning a hacker would need to compromise a majority of these nodes simultaneously to alter information, which is a formidable task. Secondly, the immutability of blockchain data is a powerful security feature. Once a transaction or data entry is recorded on the blockchain, it cannot be retrospectively changed or deleted. This characteristic ensures data integrity and provides an unalterable audit trail, making it highly valuable for verifying the authenticity and provenance of information. Lastly, transparency, while sometimes misunderstood, contributes to accountability. On many public blockchains, all transactions are visible to network participants, though identities may remain pseudonymous. This open ledger allows for continuous verification and detection of anomalies, fostering a higher degree of trust within the system. While blockchain offers compelling advantages, it is important to acknowledge its current challenges and limitations. Like any emerging technology, it is not without its complexities and areas requiring further development. Understanding these aspects provides a balanced perspective on its practical implementation. One significant challenge is scalability. Current blockchain networks can sometimes struggle with processing a high volume of transactions per second compared to traditional centralized systems. This can lead to slower transaction times and increased costs, particularly for large-scale applications. Solutions are being explored, but remain a work in progress. Another consideration, particularly for proof-of-work blockchains, is energy consumption. The computational power required to maintain these networks can be substantial, raising environmental concerns. Alternative consensus mechanisms, such as proof of stake, aim to address this by offering more energy-efficient solutions. Regulatory uncertainty also presents a hurdle. The legal and governance frameworks surrounding blockchain technology are still evolving in many jurisdictions. This lack of clear regulation can create ambiguity for businesses and individuals looking to adopt blockchain solutions, impacting widespread integration. Finally, the 51% attack remains a theoretical though difficult, vulnerability. If a single entity or group gains control of more than 50% of a blockchain network's computing power, they could potentially manipulate transactions. While highly improbable for large established blockchains, it is a consideration for smaller or newer networks. Blockchain's unique properties are already being leveraged in various real-world cybersecurity applications. These examples demonstrate how the technology is moving beyond theoretical discussions into practical solutions for enhancing digital security. Companies and organizations are exploring diverse implementations. For instance, some companies are utilizing blockchain for secure data timestamping. This method creates an unalterable record of when a document or piece of data was created or last modified. This prevents malicious actors from falsifying timestamps, which is crucial for legal documents, intellectual property, and audit trails. Another innovative application is in developing passwordless authentication systems. Instead of traditional passwords, which are vulnerable to breaches, blockchain can store cryptographic keys or digital certificates. This approach makes it significantly harder for attackers to gain unauthorized access, as the authentication relies on immutable, distributed records. Blockchain is also being explored for supply chain security. By recording every step of a product's journey on a blockchain, from manufacturing to delivery, companies can create a transparent and tamper-proof ledger. This helps verify the authenticity of goods, prevent counterfeiting, and track potential breaches in the supply chain. Furthermore, decentralized identity management systems are emerging. These systems allow individuals to control their own digital identities, rather than relying on centralized databases. This can reduce the risk of identity theft and provide a more secure and private way to verify credentials online. While our focus is on cybersecurity, it is worth noting that blockchain's utility extends far beyond this domain. Its fundamental characteristics make it applicable to a wide array of industries, demonstrating its versatility as a foundational technology. Understanding these broader uses helps contextualize its overall impact. In the financial sector, beyond cryptocurrencies, blockchain is being used to streamline cross-border payments, reduce transaction costs, and enhance transparency in financial markets. Its ability to provide an immutable ledger is valuable for auditing and compliance. This can lead to more efficient and secure financial operations. Healthcare is another area where blockchain shows promise. It can be used to securely manage patient records, ensuring data privacy while allowing authorized access from medical professionals. This could improve interoperability between different healthcare providers and enhance the security of sensitive patient information. Logistics and supply chain management benefit from blockchain's transparency and traceability features. Companies can track goods in real time, verify their origin, and ensure ethical sourcing. This helps in preventing fraud, reducing delays, and building greater trust among supply chain participants. Even in areas like intellectual property rights, blockchain can provide a verifiable timestamp for creations, helping artists and inventors prove ownership. This can protect against plagiarism and ensure proper attribution, offering a new layer of security for creative works. As we look ahead, the potential for blockchain to further revolutionize cybersecurity appears significant. Ongoing research and development are continuously uncovering new applications and refining existing ones. The integration of blockchain with other emerging technologies could unlock even greater security capabilities. One promising area is the security of Internet of Things (IoT) devices. Blockchain could provide a decentralized framework for authenticating and securing the vast number of interconnected devices. This could mitigate vulnerabilities often found in centralized IoT management systems, enhancing overall network resilience. The development of tamper-proof voting systems is another compelling prospect. By leveraging blockchain's immutability and transparency, it may be possible to create more secure and verifiable electoral processes. This could increase public trust in election outcomes and reduce the potential for fraud. Furthermore, blockchain could play a role in creating more resilient and secure digital identities, potentially replacing traditional password-based systems. This would empower individuals with greater control over their personal data and reduce the attack surface for cybercriminals. The convergence with artificial intelligence and quantum computing research also presents intriguing possibilities for future security enhancements. Blockchain is more than just the technology underpinning cryptocurrencies. It represents a significant technological advancement with profound implications for cybersecurity. While it is still an evolving field with challenges to address, its core principles of decentralization, immutability, and transparency offer compelling solutions to many contemporary security concerns. The journey of blockchain integration into mainstream cybersecurity is ongoing. It requires careful consideration of its strengths and weaknesses, alongside continued innovation. However, the potential for a more secure, transparent, and resilient digital world, where data breaches are minimized and trust is enhanced, remains a powerful vision. We hope this objective overview has provided you with a clearer understanding of blockchain's role in cybersecurity. Understanding such technologies is a crucial step in navigating our increasingly digital world. If you found this discussion informative, please consider liking this video and subscribing to our channel for more content on technology and its impact. Your engagement helps us continue to provide valuable insights. We encourage you to share your thoughts and questions in the comments section below. Stay informed, stay curious, and contribute to a more secure digital future.